Hello everyone, good morning. Today we will see what do we mean by a plane. So what is a plane? First of all, it is a geometric object, right? Now, first we identify the special characteristic property of a plane. So how do we do it? All we encounter in daily life, plane, right? For example, if you look at the wall, it is a plane. So and floor also is a plane. Now let's try to understand what do we mean by plane. For example, I took this plane, right? So this is a plane, the surface area is a plane. Now what happened here? If you take any 2 points, let's say here and here, now if you join those 2 points by a line segment, the total line segment lies on this surface, right? So that's the characteristic property. We hope this will be the characteristic property. But that hope you can use as a definition. To do that, what you have to do that characteristic property will distinguish this plane from other geometrical objects. So how is it really true? Yes, it is true, because if you take a sphere, let's say I consider a sphere. Now if you take any 2 points on sphere, maybe here and here, then if you join, then the line segment is inside the sphere. It will not on the surface of the sphere. Okay, great, we happy now, because this definition, I mean the character that identify will distinguish the plane from other geometric objects. So we will accept as mathematically this as our definition of plane. Here is the definition, but I suggest two definitions. First definition that I derive here, that I am writing. So if a subset is a plane if P contain at least 3 non-collinear points, and if you take any 2 points, then the line segment join those 2 points is the again lie inside the set, right? And the second definition I write down in term of normal. Now one thing you observe here, that look at this plane. Now if you take this plane, now here this is my plane, right? Now see, if you take any point on it, and if you consider here, imagine a perpendicular line. Now if you take any vector here, that dot product will this imagination line will be 0, right? So that also a characteristic property. So that I write here. A subset is a plane if it contains at least 1 point, the point that I consider. Now there is a vector n such that non-zero vector such that the P will be the collection of those points. Here, if you join the point with the base point A, the vector you get will be perpendicular with that imagination non-zero vector, right? That I write here. So great. Why I write two definitions? What is the difference between, what is the convenience with definition 2 or with definition 1? What is the better definition? See, one thing is clear that the definition 2 contains more mathematical terms. So therefore it will allow us to write down the mathematical equation of a plane, right? Perfect. Clearly. But we will be happy, if we can prove these two definitions are equivalent. I mean, if any subset P satisfies the definition 1, then the subset will satisfy definition 2. And if we can prove that subset satisfy definition 2, then it will satisfy definition 1. Exactly I did it here. First I prove definition 1 to definition 2, then definition 2 to definition 1. That's the proof. So this is the way how you can do geometry. If you have any geometric object, then you can understand that geometric object, different type of property of that geometric object, if you can convert in algebraic language, right? So that's why the algebra, because in algebra you have lots of equations, lots of tools, you can use those tools to understand geometric object. It is I did for a basic geometry, but you can do for more higher math like Riemannian geometry, hyperbolic geometry, lots of geometry there, and you will definitely enjoy the real world, because nature is a geometric object, right? So that's why we need to understand geometry, and geometry you can understand until now using algebra. So that's why I like algebra as well as geometry. So hopefully you all enjoy. Thank you so much. See you in the next video.